Jupiter isn't just the largest planet in our solar system. It's a planet of superlatives. With its massive size, powerful storms, deadly radiation, and intricate system of moons, Jupiter is a celestial wonder that never ceases to amaze. So, let's start with some mind-blowing facts about this gas giant. Jupiter is more than 11 times wider than Earth and has a mass that's 318 times that of our home planet. It's so massive that its gravitational influence extends far beyond its immediate vicinity, affecting the orbits of other planets and asteroids. One of the most iconic features of Jupiter is the Great Red Spot, a gigantic storm system that has been raging for at least 400 years. This anticyclonic storm is about twice the diameter of Earth and exhibits wind speeds of up to 432 kilometers per hour. Recent studies suggest that the storm is slowly shrinking, but it remains one of the most studied atmospheric phenomena in the solar system. But Jupiter isn't just about size and storms. It's also a planet with a rich and complex system of moons. Jupiter has 79 known moons, each with its unique characteristics and scientific interest. Let's talk about the four largest ones, known as the Galilean Moons: Ganymede, Callisto, Io, and Europa. Ganymede is the largest moon in the solar system, even bigger than the planet Mercury. It has its magnetic field, a rarity among moons, and its surface is a mix of water ice and rocky material. Scientists believe that Ganymede may have an ocean beneath its icy crust, potentially containing more water than all of Earth's oceans combined. Next, we have Callisto, the most heavily cratered object in the solar system. Its ancient surface has remained largely unchanged for over 4 billion years, providing a window into the early solar system. Callisto's lack of significant geological activity makes it a fascinating subject for studying impact cratering. Io, on the other hand, is the most geologically active body in the solar system. It's home to over 400 active volcanoes, driven by tidal heating from its interaction with Jupiter's immense gravitational pull. The volcanic plumes of Io can reach heights of up to 500 kilometers, constantly resurfacing the moon and creating a dynamic environment. And then there's Europa, perhaps the most intriguing of them all. Europa's surface is a vast expanse of ice, with cracks and ridges hinting at a subsurface ocean. This ocean, kept warm by tidal heating, could harbor conditions suitable for life. Missions like NASA's upcoming Europa Clipper aim to explore this possibility by studying Europa's ice shell and potential plumes of water vapor. Jupiter's magnetic field is another mind-blowing feature. It's the strongest of any planet in the solar system, about 20,000 times more powerful than Earth's. This immense magnetic field generates intense radiation belts, capable of damaging spacecraft. Jupiter's magnetic field also creates stunning auroras at its poles, visible in ultraviolet light. These auroras are not just beautiful. They're powerful indicators of the planet's magnetic environment and its interactions with the solar wind. The magnetic field is generated by the rapid rotation of Jupiter's metallic hydrogen interior. This exotic form of hydrogen, which behaves like a metal due to the extreme pressure within Jupiter, facilitates the creation of a dynamo effect, similar to what we see on Earth, but on a much grander scale. Jupiter's atmosphere is a complex and dynamic system, composed primarily of hydrogen and helium with trace amounts of methane, ammonia, water vapor, and other compounds. The upper atmosphere is divided into several bands of clouds, which run parallel to the equator. These bands, known as belts and zones, exhibit different colors and are driven by Jupiter's fast rotation, which completes a full turn in just under 10 hours. The belts are darker, warmer, and host high-speed winds that blow in opposite directions to those in the brighter, cooler zones. This alternating wind pattern creates turbulence and leads to the formation of vortices, including the Great Red Spot. By studying these atmospheric dynamics, scientists can gain insights into the weather patterns and climates of gas giants, both in our solar system and beyond. Understanding Jupiter is crucial for several reasons. Firstly, its immense gravity has played a key role in shaping the solar system. Jupiter's gravitational influence has helped to clear the region around its orbit of debris, which could have otherwise posed a threat to Earth in the form of cometary and asteroidal impacts. Additionally, studying Jupiter's atmosphere and magnetic field provides valuable data that helps scientists model the behavior of exoplanets, many of which are gas giants similar to Jupiter. And let's not forget the Juno mission. Launched by NASA in 2011, Juno has been orbiting Jupiter since 2016. Equipped with instruments designed to peer beneath the planet's thick clouds, Juno has provided unprecedented insights into Jupiter's interior structure, gravity field, magnetic environment, and polar regions. The data collected by Juno is helping scientists to understand the formation and evolution of Jupiter, shedding light on the processes that govern giant planets. Juno's discoveries have been nothing short of revolutionary. For instance, the mission has revealed that Jupiter's core is not as dense as previously thought, suggesting it might have been struck by a massive protoplanet during its early formation. Additionally, Juno has captured detailed images of Jupiter's polar cyclones, showing complex and chaotic weather systems that are unlike anything seen on other planets. As we continue to explore Jupiter and its many mysteries, each discovery brings us closer to understanding not only this giant planet, but also the broader mechanics of our solar system and beyond. Jupiter's influence extends far and wide, making it a cornerstone of planetary science. Being here, sharing the wonders of Jupiter with you, makes me feel like a small child gazing up at the night sky for the first time, filled with boundless curiosity and pure delight. It's moments like these that remind me of the infinite beauty and mystery our universe holds. And now let's talk about Jupiter's magnetosphere, the area of space controlled by its magnetic field, which is immense. It extends up to 7 million kilometers in the direction of the Sun and nearly reaches the orbit of Saturn in the opposite direction. The magnetosphere captures particles from the solar wind and Io's volcanic eruptions, creating intense radiation belts. These belts pose significant challenges for spacecraft missions, necessitating careful planning to avoid excessive exposure. Speaking of challenges, let's delve into the intricate dance between Jupiter and its moons. The gravitational interactions between Jupiter and its moons create complex orbital resonances. For example, Io, Europa, and Ganymede are locked in a 1:2:4 resonance, meaning that for every orbit Ganymede completes, Europa orbits twice, and Io orbits 4 times. These resonances play a crucial role in driving the geological activity on these moons. Jupiter's rapid rotation also has fascinating consequences for its weather systems. The planet's rotation causes a flattening at the poles and a bulging at the equator, making Jupiter an oblate spheroid. This rapid spin generates powerful jet streams that separate its cloud bands, leading to the turbulent and visually stunning atmosphere we observe. Now, let's take a closer look at the unique phenomena occurring at Jupiter's poles. Unlike Earth's polar regions, which feature relatively calm weather, Jupiter's poles are home to massive cyclonic storms. These polar cyclones, observed by Juno, are arranged in geometric patterns, such as octagons and hexagons, creating a mesmerizing and mysterious sight. Understanding these polar cyclones helps scientists uncover the dynamics of Jupiter's deep atmosphere. Finally, let's discuss the role Jupiter plays in the broader context of planetary formation and the search for life. Jupiter's composition and structure offer clues about the conditions in the early solar system. By studying the gas giant, scientists can refine their models of planet formation and the migration of planets over time. Additionally, the potential for life in the subsurface oceans of moons like Europa and Ganymede makes Jupiter a focal point in astrobiology. Jupiter's ability to capture and retain so many moons, ranging from tiny irregular satellites to massive Galilean moons, showcases the diverse processes at play in the planet's history. Each moon provides a unique glimpse into the past, helping us piece together the story of the solar system's evolution. Host: enthusiastic. Whether it's the mind-boggling storms of the Great Red Spot, the volcanic fury of Io, The potential subsurface oceans of Europa or the ancient craters of Callisto, Jupiter and its moons offer endless opportunities for discovery. The more we learn, the more we realize just how dynamic and complex our solar system truly is.